So let's make sure you guys can hear me okay. Looks like you can. Let me pop over into my streaming. You guys should be able to hear and see me. Okay, good. All right, so my name is Scott Champagne, and I am recording Linux Automation Unit 4 for the Professional Linux Users Group. This is our automation course that you can get involved with for free down in our Discord if you want to. And let's get right to it. This is our fourth class meeting. We are back on schedule, so we're completing this. I don't know, I think we're doing this one for 16 weeks or something like that, so this one's going to be going for a while. But we've been recording each of them, and you can find all that down in the Discord if you want as well. So if you have questions, ask me them in our Discord and all that good stuff. All right, so last week we participated in kind of this exercise around what is an inventory, and we answered a bunch of questions around that in our discussion. If you do the course with us, you have to have one response to the questions and then one response to somebody else. And the reason we do that is there's a few reasons, but the first one is in any academic setting, the ability to properly articulate your ideas and then argue for them and their value and their merit and those kind of things is valuable. And then also, because if you're going to do this stuff professionally, people are going to look at your work too. So you can't really sit around and be worried about somebody, viewing your work a certain way because they're going to look at your work anyways. So we did that. We talked about the implications of a poor inventory management system. Some security engineer walks up to you and tells you, hey, you have this number of servers, but you thought you had a different number. How do we reconcile that, right? Then we had a worksheet and a lab, and we were talking mainly around the course objective. We have a syllabus with all the course objectives, maintaining inventories for system automation and activities. So that was a major course objective that we were hitting last week, and we're going to review that a little bit this week before we get into the next part. So Unit 3 is a quick overview. What were our inventory files? They can come from flat files. They can come from API calls. You can get them from all kinds of sources. What's the importance of having a good inventory? Like what comprises of a good inventory? It should be accurate, readable, useful, right? All of these things have different characteristics of them that kind of make a value to the thing. Okay, so inventories are structured, useful lists of items. They don't have to just be servers. They can be people's names. They can be API endpoints, website endpoints. They can be all kinds of things. Certificates, right? If you have a bunch of certificates you manage through automation. We tend to use semi-structured lists, maybe flat files that are ordered with new line characters, comma-separated values of some type, just CSV type values, JSON or YAML. There's a bunch of different ways that we can put inventories into our system. We can put them in via API calls, which tend to come back in JSON, and then we parse those down and we read out the pieces we need. We can have environment files that are given to us in YAML or CSV by different engineering teams that we maybe interact with. And we're going to kind of continue with inventories throughout the whole course, but this first week kind of level set for us on that. Inventories must be maintainable, right? You have to be able to read them yourself. Now, the system has to be able to read them too, but you have to be able to look at them and go, okay, that makes sense. Because if you can't parse an inventory quickly, then you can't maintain it. That's for sure. So, all right. Importance of a good inventory, right? You cannot interact with what you do not know exists. You cannot react to problems on things that you're monitoring or not monitoring or things that you don't know exist there. And then you can't secure that which you don't know about. So I like to think of it as the fog of war. If you've ever played a game and you've mapped out the terrain, but you don't have guys in a certain area so you can't see things, that's a lot like what a bad inventory is. Bad inventory in your system, an incomplete inventory in various ways will cause you to not be able to see things. So this, again, is a review from last week. So last week kind of touches on this stuff more, but that's kind of our high-level review of that. What makes up a good inventory? It's complete. It has all the systems under your purview, all the systems under your controller in it. It's accurate, and it sees the systems in the way that the system needs to see them. So if you use fully qualified domain names to get to different places, cool. If you use shortened names, cool. If you use some kind of aliases, sure, that's fine, as long as the system that's going to run the inventory has access to use those aliases. A good example of this would be if your inventory comprised of like name, space, scoped, Kubernetes values, but you're going to be calling things outside of that namespace from inside of a container or a pod inside of, you're going to have problems because you need to use the fully qualified domain name to talk outside of a namespace. You can't use the short name. So these are things that you might think about as you build inventories. And we're going to get more into the Docker and Kubernetes stuff in the coming weeks. But a good inventory is properly formatted, it's semi-structured in nature, and it follows whatever the rules of that language are. Because if not, it can't be parsed, it can't be read, can't be fed into the system, everything breaks. And then a good inventory is also automatically updated. If you have processes running to automatically build servers, they should be checking those things in and that kind of stuff. If they're not, you need to figure out how to do that, and you need to get that going. So these are things that we kind of look at. Okay. Some views of inventories, and you get these in the lab, so we won't go over these again, but we compare. These are two same inventories, but just in different formats, and I ask, are they maintainable, that kind of stuff, something to think about. All right, here's another set of inventories where it's an environment file. Somebody gives you some CSV, some project manager, or your manager sends you over things and says, hey, pull this information. Do these servers see these IDs of users? Well, now you got to parse this down, and you got to figure it out, and there's all these things that you might have to do. So, inventories are important. So that's kind of our review from last week. This week, we're talking more about, so again, back to discussions. You got to do your discussions. Those are up in the Discord, by the way. So if anybody's ever like, hey, I'm interested in doing this course, how do I go get involved with it? You go right here, and you go up to the course discussion posts. And you would put in, let's say you wanted to do the automation course, you would go here to automation course, and it would show you just the post that you have to now catch up on. Because if you want to catch up to Unit 4 and get our cool little cert, we give a little certification out for people that finish the course. We typically have about 100 people start our courses. Maybe in some cases we've had almost 200 people start some of our courses. And we only have about 5 to 10 finished because it's a significant amount of work to do some of this stuff. So. Plan accordingly if you want to try to do that. I think it's valuable to go through it even if you're not going to get the cert, but that might just be me because I'm the guy putting the courses together. The first discussion is refresh cycles and stopgap measures. So I'll show you that here in a second, and we'll look at what that question kind of entails, but it's the idea that something's happening in your organization. You have a way that your organization goes through refresh and buys new equipment. This is very common in most organizations. We've got a budget. We know how much we can spend for each of the next X amount of years, and we allocate a certain amount of time or a certain amount of money and time to refreshing our aging fleet of servers, physical servers, virtual machines. If we have like ESXi on physical machines, and then we're taking those out and putting new ones in, and it's just how do we refresh our servers? How old do we let our servers get before they have to be broken down and pulled out of our environment? Those kind of things. So we're going to talk about that. And the stopgap measure specifically speaks to capacity. If you are, having some type of problem of capacity because your equipment can't handle the load or the new users or the popularity of your system, then maybe there's some things to think about there. And then we talked about keeping an inventory updated, which kind of piggybacks off of last week's. That security engineer gives you some set of information that's different than yours, and how do we go about truing those things up, and then how do we keep those true going forward. We got a worksheet. We'll look at the worksheet, and then we have a lab on admin commands or one-off commands. In Ansible, we call them ad hoc commands. But how do we keep a running system going with things that are automations, but they're not quite all the way back over on the engineering side of things? So I'll kind of show you a little cycle that works through that and helps you to digest the way that different commands work, that kind of thing. And our course objectives are, we want to be able to deploy our various automation tools for the job that we do and the things that people hire us for, right? Because people hire us to do admin and engineering work, and then in this case, we're doing automation of those things. And then we're maintaining system configuration. That's a big part of this. And remediation of drift, this is more of like bringing the system back in line with maybe what user expectations were, but that's a drift in a certain sort of way. All right, so our overview. We're going to talk about administration and one-off commands. What are they? What triggers them? How do we get into a state where we need to interact with our systems a certain way? And then one-off commands in our different automation tools. This week's lab heavily leans on Ansible. Most of the stuff going forward will, because it's not an Ansible course, it's an automation course. I mean, we use Bash sometimes, we use Ansible sometimes, and we use Python sometimes, but we will use the right tool as we find fit for the job. So that's kind of the goal of this as we go. Okay, so admin commands are commands that change running systems. So you've got operations over here, keeping systems at whatever type of uptime we want to keep in our organization, typically 100% if we can, but typically represented as some number of nines that we call like 4 and 5 nines. And we try to keep our systems operational, right? That's what we do. And the things that we do as an admin, you know, down at a command line, is we observe things. We run commands. We observe a running system in the state that it is. And I made this point to point out, when you observe a system, you're not strictly speaking changing something, but you are making changes on that system. And in the purest sense, just so you know, if we back up all the way, to even SSH into a server, to log in as a user, and maybe for the first time my user connects and odd job goes and makes me a home directory, and then Skell gets copied in, and I've got these new systems. Maybe I even copy over my bash RC and some other stuff for my lab, or for my bash customizations and stuff. By observing that system and going and running like an uptime command, I have made changes to that system. I've made log file changes. From a purist standpoint, I am touching that system. So it's kind of important to understand there. And then benchmarks load, spin up the system in some way, see how the system behaves when we set it to a certain amount of load. Hey Boris, how's it going? Thanks for the gifted subs. Hopefully people don't have to watch ads for a while now. That's always nice over on the Twitch side. And then another one, this is an important one as an admin. We tune things. We change system configurations in some way. And then typically we got to restart services for those to take effect. But these are the primary things that we kind of do as an admin on a system. If we're running around maintaining a set of servers and keeping them on and aware of what's going on, and we're keeping systems happy, we are observing, benchmarking, and tuning those systems, okay? And there's, I mean, I guess there's some edge cases, but I would say this paints a pretty wide brush of most of the things that you're going to do as an admin. You're either looking at stuff or you're setting things. And then sometimes you're spinning up load to see how a system behaves in different ways. Okay, so those are admin commands. What causes us to kick off admin commands? So I'm an admin, I'm sitting here. What triggers me to do things? Well, obviously, some kind of ticketing system, right? User requests come in, and those requests are either simple enough for me to do, and they fall into maybe like what we call standard changes, and I can approve them, or their management can approve them against their assets. I can give access or permission. So you come in and you say, hey, you know what, we got this new guy on the team, and we've got a dev environment, and he's going to primarily work in those 3 servers in our dev, right? Not prod facing, not customer facing, some dev environment. I may have the authorization to give them sudo access to be root on those boxes for a reasonable amount of time. That may be something we actually give. In fact, previously in companies, I've actually built that in where the requester gets root on the servers that only exist in the environment for 2 months. So we had a class of dev servers that were specifically for like proof of concept testing, and they only existed in our environment for 2 months before they would shut off. And when a user asked for them, they automatically got sudo permissions granted on them. And that's something that you might have to think about and consider as a user. Anyways, maybe we need to fix or configure an environment. So this is actually going to be a big part of our lab. Users are going to send in requests, and they're going to say, hey, you know what? The engineering team built this thing that we asked them to build, and they put an Apache web server on it, but it didn't come out right. Can you just go fix it? And yes, sometimes if you have 20 developers sitting there on their hands not doing any work because an environment is not correct, there's 2 ways you can handle that. You can go, well, we're going to go all the way back. We're going to go all the way back to 2 weeks ago when you guys got in that meeting and you guys planned everything out, and then the security or our engineering team built out the automation to deploy it all, and we can go fix that. And retooling that and testing that's probably going to take a day or 2. Yeah, we'll get back to you. That's one way to do it. Or the other way is just to fix the environment, right? And we do one-off and admin type commands to fix an environment. And then we take those commands and those things we did, and we feed them back into our build process so the next time that we do it, it's better, if that makes sense. And I was telling you guys, as we were talking about this last night as the group, In a perfect world, yes, we would always dance back to the beginning and fix everything perfectly and redeploy an environment and pat ourselves on the back and everything would be perfect. But we have time constraints, we have cost constraints, we have, what's the next fire or, incident that's happening constraints. So sometimes we've got an environment up and it's 95% of the way there and we've just got to fix it. Yeah, we do need to investigate our process. We do have to do some quality management and make sure that things are better the next time in the automation that deployed a thing. But admins and administrators have to make things right in an environment all the time. I kind of think of it as like you're just outside of the, you're driving down a road and there's like the old cart trails and there's like the grooves and you're just outside of the grooves and all we got to do is get you back in there and then you're riding along the right way, right? So this is kind of something to think about, right? Like some users can happen. Things can happen in an environment. There's all kinds of events that can happen. A service or a server can stop responding. The levels of that tend to be in this order. Like a service will turn off. Proxmox runs on 8006. Grafana runs on 3000, right? 3000. Maybe that service just becomes unavailable, and that's our first check. And then we go and we try to get access to the server. Maybe we can't SSH in, so we ping it. Don't even see the ping, but we're still resolving DNS, so we still see it in our IPAM. It hasn't been removed from inventory, our IP address management, but we can't ping it, we can't hit it. So we go to the console. Can we get to the console? Well, if it's physical box, we're using IPMI, Internet Protocol Management Interface, or any of the various tools to get into that. Or if it's a virtual center, we're going into like a vConsole and connecting to it that way, but maybe we can't even get access to it there. Like, what happened to the server? What the heck? These are the different levels that something might be busted, and we may have to go and remediate that and figure that out, right? If a service is just unavailable, but you can get into a server, you might restart the service. You might restart the service and then check the logs, all these things that an admin might do, right? We might get log events or alert triggers. So we might have some kind of SIEM, security information and event monitoring, right? And we can get some kind of trigger that says, hey, a user was added on the server. It's in a prod environment. Users should never be physically added to into a system like an Etsy Pass WD. No, users should always be coming in through like our Active Directory or our LDAP type implementation. So that alerts the trigger, and then maybe we go clean that up in some way with an automation, right? These are the types of things we might do. We might live in an event-driven environment. So Kafka, SQS, Splunk, there's so many other ones. EventBridge is a big one if you're up in AWS. Kafka is a good one that like is very vanilla for a lot of different environments. And I first ran into Kafka in high performance compute because people started dropping it down so that logs could go to Kafka and then Elasticsearch could pull them out. Elasticsearch or OpenSearch, whichever one you're using, right? There was a fork of those a few years ago. But both of those are still valid. Both of those are still usable. But event-driven is some event is triggered and some other, so producer is producing events into an environment and then the consumers are out there listening for it and then doing activities on servers and securing things depending on what's going on. So there's all kinds of things that can happen. And then again, security findings and security incidents can be triggered from events as well. So there's all kinds of things that can cause you to go into one of these admin type modes, right? So how does that kind of look? So where does this happen? So this right here, the PPDIOO deployment methodology, this comes originally from Cisco, and this deals with how we deploy systems, right? But what I want to show you, this comes from another talk that I have on Linux administration. But we're over here as administrators a lot of times operating and optimizing systems. So operations, I said in that example, a server came up and it wasn't correct. An environment came up for some dev team and they reach out to you with a ticket and you need to go do some ad hoc or admin or, one-off type command to get that environment the way that they expect. Now, if that environment was redeployed, would we have a solution with our one-off command? No. We would, if that environment ever got redeployed, that error would be redeployed, re-injected as we think of it. So what we then need to do after we do our ad hoc and our one-off commands, we need to plan to put that back over here into our implementation so that all of our stuff comes up clean. Sometimes it's easier when this is the same team, when this is the same people doing this stuff, right? But again, ad hoc and admin commands, we're keeping the lights on. That's what KTLO means. We're keeping teams from being down. So a dev team expected their environment to be up on Monday morning. It was, but it wasn't working for what their team needed. We come in, we get it working really quickly, right? We do these things kind of quick, and then we work that back into the build later so that the next time it comes up, we don't have these problems, right? I kind of think of this as like, if you guys have ever seen somebody like doing grout over tile, or they're moving, you know, they've got whatever design they want for like pavers or something, and then they're putting that dirt or grout over it so it sinks into the little edges. That's kind of how I think of this. Like, we have the environment set now, you know, the way we want, but maybe we just have to fix this little bit of stuff. So we're just kind of going over it with the grout, or we're going over it with the little sand, and then getting it into all the little areas so that the next time it deploys, it's a little more, it's a little more fixed and correct. So that's just my way of thinking about it. But PPDIO is a great way to think about system design, right? Prepare, plan, design, implement, operate, and optimize. And we're over here operating and optimizing our systems. So before we move forward, let's go look at this week's worksheet. So the worksheet, I just dropped this to the guys a little while ago. If you're doing the course with us, this is one of the things that you would fill out and you would work through as you do this week's work. We average somewhere between like 8 and 10 hours of work a week. I'd say this week, this stuff that I put together, I don't think this would take you but, I don't know, maybe 4 or 5 hours. But in general, we try to do about 8 to 10 hours of work. And then there's also study groups in our Discord for people to go and work through this stuff if they need. So what are we doing this week? We come down here. Here's your discussion post 1. And it says your company is on a normal 3-year refresh cycle for hardware. That's pretty standard. Maybe not all organizations have that, but some organizations are going to have that. Some organizations are going to be on 5. Some organizations, they don't even know. They just buy stuff when it breaks. That's a little less mature, but it depends where your organization is. But what does that mean? So I got a little on my soapbox here. What does that mean? It means that they purchase about 1/3 of the hardware each year in the budget. So you've got 1,000 servers. You're replacing about 333 each year. And you have 6 months until the next purchase, but you've been having storage capacity issues in some of your servers. Don't have anywhere to put data, right? Your team sits down and works out a plan to put in place what they call a stopgap measure to fix the system and keep it running until the next deployment. So what I'm asking here for you guys to do, if you're doing the course with us and maybe you're trying to get into doing this stuff professionally, what is a stopgap measure? What does a stopgap measure mean if, you know, some Java process keeps filling up over the course of a week and breaking maybe your Tomcat implementation on a web server, and the team figures out, right? You work with the dev team a little bit, and they figure out that, oh, you know what, it's perfectly fine. It's behind a load balancer. We just restart it once a week. That's a stopgap. That's a stopgap until we can get the fix implemented so that whatever this memory thing isn't happening anymore. And I'll tell you, like a lot of times on us, on the Linux and server side of things, Java can be especially nefarious in that we can't see into it. It's a black box to us. It's almost, I think of it almost like I'm looking up and it's just like a balloon. Like, you ever seen one of those like black balloons that's like filling up? I don't know, like one of those shows where they like make people do weird tasks or whatever. And you're sitting under this balloon, it's filling up and you can't see what it's doing. And then one day it just kind of like pops or whatever. And that's kind of like how I think of Java. You don't really know what it's doing inside of it if it's not reporting it out to you. If you're on the admin and the server side of things. So where I'm going with that is then I say, what is your understanding of the term stopgap? You've done a little reading about it. Maybe you've thought about it a little bit. What's the term? And then I say, what are some things that you would be doing to help a system that has no way to add capacity before a certain time? Would you tune up the monitoring? Would you maybe touch that server every morning to check the value? Would you be updating your system and your team's documentation so that maybe the on-call or the overnight knows to check, because maybe sometimes this thing fills up during, you know, batch backups between like 2 and 4 a.m. or something? Like, there's all kinds of things that we might need to think about here. And then I say, what is meant by the term, this is fun, you may hear this, you will definitely hear this as an engineer. What is meant by the term draconian measures? Now, you've probably heard draconian measures in the concept of like, people say it for politics and law and that kind of stuff. But what does that mean in a systems engineering thing, especially around the concept of capacity and stopgap? So think about what are draconian measures, because you're going to hear that term in your engineering career. And what would that be? What would that mean? All right. Our other discussion is a continuation of week 3 discussion. So you'll have to have done week 3 to kind of get what's going on. But you and your security team have an accurate inventory after last week's misunderstanding. So in last week, you thought you had 100 servers. The security team came to you with a list of 110 servers and their vulnerabilities, and you went, what the heck? There's something wrong here. I thought I had 100. You thought I had 110. What's the difference, right? So you have 110 servers. You've found that there's 110 servers currently in your inventory. What are some methods you can use to verify those systems are operational? Do you ping them every day? Do you netcat them every day and just make sure that the service is up? What do you do? How much you touch those servers every day? And then how much you plan to keep those inventories updated automatically, right? What are some things that you might do in your system? Now, you might go look for tools that are out there. You might look for methods that other people are doing. One of the guys was talking about, as we were talking last night, he's like, well, I'm in AWS, so I know all my servers. And I'm like, you know what? It's actually interesting. If you work with somebody who does managed services to you, they will always have a perfect inventory. You know why? Because they're going to charge you for everything. So that makes sense. They've got a perfect inventory. So you should use that inventory because that's a good one. Same thing with Satellite. If you guys ever use Satellite with Red Hat, those are all the licensed servers you have are going through Satellite to get your updates. So Satellite's an excellent inventory source because everything that you want to do to maintain your servers also goes through that. So it's a great way to true up your environment. But I say how much you monitor these servers. If you've been through the courses before, maybe you're familiar with Grafana and Kibana and some of these other tools that we can use to monitor things. There's no answers here that are different than other things we've done in other courses because, well, it might surprise you to find that I'm not trying to trick anybody here. I'm trying to make you guys use the industry standard tools. So it's all the same. How much you present a report of these servers to your team or others? Would you send them out like in Discord, right? Like we send every morning, we've got down in the sandbox a little check. What's going on in the environment? How do we do these things? We also added, if you check in the ProLUG lab environment channel, you can add a key and get access, right? There's a command, Fisherman put it all together for you guys to be able to just drop a key in there, do add key, and it'll pull your key in, and then you can log directly into the system. Here's some definitions and terminology, things that I think you just need to know or read about, right? These are things for you. What does it mean to have a stopgap fix? How does it relate to full implementations? What are we doing with a stopgap, right? What does it mean to have a stopgap? Like we know that there's a problem. Maybe there's a pressure that's building. There's a high water mark that's being moved up every week, and we have to do something else with it. So what are we doing there? And then maybe what is a systemic system problem? Like we're doing something wrong and we can't handle the capacity. Or if we have a systemic capacity problem where maybe we're doing things right, but we're just blowing over the top. We just can't handle the amount of users that are coming in or the amount of storage that we're using or whatever, right? So this is you've planned improperly, or this is you've implemented something that's not working correctly. This is you've planned improperly for growth, right? So there's different types of problems. And then I talk about system load and utilization. Now, when we talk about system load is not a percentage. System load is relative to the number of CPUs you have, typically, if you're talking CPU. But system load is how much of something you're using. Utilization is always a part of 100%. Between 0 and 100%. Utilization is always how utilized is something, right? So there's averages, there's high watermarks, low watermarks. What is spiking? Spiking is certain amounts of standard deviations away from the norm. We don't need to get into that if we don't need to. But if you want to get into, if you back up and say, Scott, I don't want to look at this as a just a systems engineer. I want to look at this as like a quality management engineer. Then we start to talk about standard deviations from the norm and how far away from the mean are we. And then we start to think about like what are the high outliers and low outliers and how do we deal with those, right? So there's things that we can do there if we needed to. And then there's also capacity. Some of these things are exercises you hope to not have to deal with too often as an engineer. You hope everything just kind of runs, but sometimes you have to deal with them. All right, outside the scope of this. And then there's our lab assignment. So we're going to do our little lab here in a second and look through kind of some of the pieces of it. And then digging deeper, I say to go and look at the Ansible ad hoc commands because I'm a big fan of these ad hoc commands here. I think that you'll find a lot of value. Let's go to dark mode. Here, looking at maybe ad hoc commands are admin commands in some way, but they're also just kind of like little one-offs. So they show you how to use them. They show you what servers you would hit, because that's very important to understand what inventory you're running against. And then they show you different things that you might do, pushing files around an environment, managing packages and adding stuff to a server if you need to, all that kind of stuff. Okay, so and then reflection questions. Reflection questions and digging deeper are always for you. You should go spend time in there. What do you learn when you read about these things or work through them? And then how are you going to use that in your current or your future automations? Because that's, at the end of the day, you know, if you just sit in a class and nothing changes, then the class and maybe your attendance of it was not really effective or useful, right? So then I always have these questions for you. What are you still having questions about? What do you need to work with each other and talk in the discussions about more? And then how are you going to use what you've learned in your current role? And if you don't have a current role, but you're trying to get into like systems administration and engineering, then maybe this is, you know, hey, I'm going to update my resume for my next role where it says that they want me to know some certain types of automation. I'm going to include some of these things that I know how to do. I know how to implement automations. I know how to set up inventories, and I know how to do one-off admin commands to do basic tasks in an environment. That would be a perfectly fine start if it were a junior role that you were going for. Okay, so that is the automation worksheet. Then we've got a lab and a lab book. But let's go look at the Unit 4 lab. By the way, all the other unit labs are up here in Killer Coda, but we're going to go into Lab 4. If anybody wants to do it with me, I will link it for you guys here. Boom. And boom. So this will pop up. And the goal of this is to get you, again, thinking about just one-off admin type things that you could be doing. So, welcome ProLUG Automation. And here it says, your lab, this lab is designed as part of a larger set of instruction that is free from the Professional Linux Users Group, ProLUG. The lab book can be found here. So you can click here, and you can get in the lab book. And again, Unit 4 will be up soon. I just gave it to the guys this morning. But Unit 4 is dealing mostly with admin commands and one-offs, right? So here's a table of contents. If you say, hey, what's this course about? What have these guys already been through? We talked about executing your automations, interacting with the operating system, and building inventories. These are huge things that I think that you guys need to kind of understand how to do. And then you can go through and look, they keep linking all the old versions of this for you. So you guys have all the stuff you need there. Okay. So your team, your deployment teams have recently created a web server for a dev team. So you've got some team that's out there deploying web servers or deploying dev environments of some type. And you get a ticket that one of the environments is not as expected. Okay, so you get a trouble ticket of some kind. That was one of the triggers that we said earlier. I say use ad hoc and one-off administration commands to fix the environment and get the correct operational state. So the expected state is we're going to have dev port 8080, test port 8081, and QA port 8082 on presumably some web server. Oh, it says up here it's a web server. Good. We come down here and I say simulate the deployment. This is what would have happened before the ticket was put in, and you're running it to set up the lab and watch the output. So we run this first command, and it's going to set up this environment for us again, which is going to be 8080, 8081, and 8082. Those are the three environments that should be stood up here. And maybe we have the luxury of going and looking through the logs and seeing this, and maybe we don't. But in this lab, we get to actually watch this get set up on the other server. So there's a control plane and a node 01, and this is going against that host file and running it. Now, the host file and the inventories that we run into, you need to, be able to read through them, but that was last week's lab, so if you don't understand inventories, you got to go spend time with it, right? Can't always be going back and picking everybody up all the time. Sometimes it's go RTFM, read the field manual, and then get back up here when you're ready, right? So it says here that it deployed that environment. I see no errors, right? I see no errors. Like my Ansible completed, I have 7 OK and 6 change. I see no unreachable, and I see no failed tasks. So to the dev team or to the deployment team, that's a success. They deployed the things. They had been in a meeting. They got their numbers 80, 80, 80, 81, and 80, 82. Good. They've deployed it. It worked. Everything's good. Maybe they even got it from an inventory. I don't know how they got it into here. Maybe they got an environment file from the dev team. Maybe some project manager jotted down some notes and knew the format and did. We don't know how they got to this, but we know that the system ran and worked. But it's not what they expected. They put in a trouble ticket. So you're going to go check and you're going to say, well, I'm going to just go hit all those web pages. And I see the dev page on port 8080. I see the test page on port 8081, but port 8082 craps all over itself, can't connect. Now, you might look at this and figure it out. That would be good. But then you might come down here and say, well, that's not exactly the best way to do this automated. We might do something like this. So we might do a little bash loop, right, which is a type of automation, and loop over all those. And we see the same thing. We can't connect to port 8082. Something's wrong with that server. So what can we do? Well, we could go over to that server and look in there. But maybe for some reason we want to check it from this node. And we might do something like, so I say how much you find what's broken. You might do like an nmap. And nmap is a great tool to see things from the outside. If you're internal, I would advise using SS or NTUL, SS or netstat. Although netstat's going away, so SS is kind of the more modern way. But let's just look at this node real quick. We see port 22, we expect that. Port 80, well, they left port 80 on the web server. Maybe for security reasons we need to turn that off because that wasn't explicitly said. So maybe that's one thing we turn off in our environment. But then we've got 8080, 8081, and 8087. That's weird. 8087 is not a normal port. In fact, it's Simplify Media, apparently. If you want to know where that's mapping from, you can grab 8087 from Etsy Services, and that is where it should be mapped from. But apparently it's not in there. Let's try this one. Anyways, I don't know why that's finding. Maybe that's just how Nmap looks at it. But Simplify Media is what it thinks that is, but that's not what we're using. We're trying to use it as our QA port, right? So we come down here and maybe we see that somebody fat-fingered an otherwise incorrect port from 8087. They should have done 8082. So we go, okay, we know we need to fix that. Well, how are we going to fix that? Well, this goes back to that one-off and just kind of quick and dirty type commands. We can go run a line and file against the Apache 2 ports.conf and change 8087 to 8082 just like this. Now, if we do that, it says that it was changed over there, and we can go SSH over and check that. But if we trust our automation and our quick and dirty low command, that should fix it. But then I go and I check it, and I see that it didn't change. And does anybody know why, right? So I say, you know, we checked it, it didn't change. And I say, remember, we always have to restart a service to reread that config file. So I can't assume here that everybody knows admin and Linux type topics. So maybe we go in there and we restart that service, the Apache 2 service, and tell it to go reread that file that's now correct with the port 8082. And maybe we then go nmap that node and we see the correct port. And then maybe we go look at that in curl, and now we see the right port coming out for that 8082 system. So then maybe we go and we look and see why it's busted. Oh, it looks like somebody fat fingered that line right there for the listener. When we deployed the original system and we modified things, somebody put the wrong file in here, or put the wrong value in here. That could have been read in here from this. It could have been read in again from an inventory file somewhere. Maybe that team gave us a bad information. There's one very important thing to think about here. When you're over here operating and optimizing, it doesn't matter why the thing is busted. Doesn't matter how it got into this busted state for us right now when we're trying to like get the road going. We want the road back open. We want to cover the pothole and get it going. So we're trying to just one-off and fix the damn thing. Then, like I say in here, at your leisure or as you can, you go back and you look and you go, somebody hard-coded it wrong. Probably they used some one-off command, something. We'd go fix that. We'd push that back up into our GitHub, and that would be part of how our automation tool, Ansible automation platform or whatever, would now pull the right version. Or this list, we would update the list so that it's no longer doing loop. It's reading loop as a variable from some environment file that's been loaded in, and it's the right value. But the point is, we can fix the service and fix the server live, and then go back and fix those things later. So again, and some people are going to argue, well, but we need to always have everything perfectly up to date and this and this. And I go, yeah, that's fine until you have like 20 devs sitting there at $100 an hour, and your company is, yeah, granted, it's a sunk cost. They've already spent the money because it's salary, but on the other side of it, you're wasting a lot of people's time. And that manager only has 4 days to get some new thing out, and you've just wasted 20 of his X amount of hours that he had because he's got 20 devs or whatever, and for the time that they were down for 2 days, you've wasted now, hundreds of hours of time that could have been used on the system. So my point in showing you guys this is sometimes we just do quick and dirty stuff and get it working. All right, so we come down here. Let's clear this up. It says validation successful. The next part of the lab is your team is happy that the system's updated and working properly. Cool. Now they have provided you a new file that they urgently need pushed into the QA environment. For some reason, they can't do it. Maybe they don't have permissions. Again, we're not going to go and rehash out what sudoers permissions they have on their accounts into that environment. We're just going to fix this thing because we're admins. Now, there are security considerations to just wild westing it and fixing everything, sure. But a big part of this is understanding, like, if I have the power and the requirement, especially from multiple managers telling me to do something, as long as I have it in a Teams message or an email to execute, I'm going to execute. And I want you guys to execute this as correctly as possible. So, all right. So now, see if you can push that file. So they give me some file. So I go curl node 018082. We see that environment's up. And we see that we've got this QA page. And they've given me a new page. So maybe I'm going to push the update via Ansible. And that update might look just like this. Ansible web servers -i. And then we're going to copy in this fixed QA over to that environment on that far node. And we'll get a message like this. And if you want to play with Ansible and see why so many people like Ansible so much, run it again. And you'll see this again. This isn't an Ansible course. We have a whole bunch of other Ansible labs. This is more of like an automation and using automation as an admin and an engineer. If we run it again, we'll see that it didn't have to change. And that's one of the things that's really powerful about Ansible is it validates that the file hasn't changed, and then it doesn't have to push it again. It just says, nope, you're cool. Everything's good. It just, again, kind of like that grout. Grout doesn't keep going down in between tiles. It only goes down as much as it needs. And that's kind of how I think of it. It's like almost like it fills in, right? So now we curl the page and we see fixed version 2 of QA, whatever they gave us in that file. But could we push that as a quick and dirty one-off? Absolutely, just like that. All right, so then we hit the check and it says successful. And the last part of the lab, and it may seem, almost overly simplistic, but the last part of the lab is we need a quick retooling of their dev environment. You've been so successful, they came to you with what they need, and this is what they need. They need a user named Service Ansible set up on their web server. Who knows why, guys, right? We don't always have to know why if we're fixing something for people. Dev teams probably, or the other engineering teams probably hashed it out with them before, and just when it came up, the system wasn't exactly what they wanted. But they need the user to have a different home directory. It needs to be in var chroot service _ Ansible, or some people call that chroot, instead of the normal location. Again, don't know why necessarily, but that's what they've requested. And the user must be added to the admin or the wheel group, depending on if you're on a, in our case, we're on a Debian style system on Ubuntu, but otherwise it would be the wheel group if it were a RHEL type system. And they have to have the user ID of 10,001. That works with some other tooling they already have. That is the requirement they have for this Service Ansible account. I don't know why they need that. I don't need to know why they need it. I know that that's what they're requesting. Can I do it? Right? And here's the solution. We're going to create a directory form. So we're going to push over and generate a directory form. Again, if you want to, for fun, run it again and see the kind of power of Ansible. It says, nah, bro, you're good. You don't need to do it again. If there were some kind of handler for this, it wouldn't need to run again. We don't need to set that up in any way. We could take the defaults, or we could also set other values in here. There's different arguments we can give to that module, and we can keep loading them up. But now we're going to create the Service Ansible user and give them all the correct settings that they were asked for. So we're going to do the user module here as kind of a one-off command. And it says that it's going to go over there. They've got the group 10,001, and they've got they should have the user 10,001. Yep. they've got this home, and there's an interesting little message that comes up. There's a warning that says that directory's already there, so I didn't make it for them. And I didn't copy the Etsy Skell directory into it. Is that important? Well, depends what that user's doing. If that user's ever logging in and relying on a default bash RC, that's absolutely a problem. But if it's not, right, and I say right here, what warnings do you see? Might you need to fix these? You weren't told to fix them, but just to be fair, a dev team and a manager that's moved up through dev may not understand all the underlying proclivities of a Linux box. So this may be something that you need to go fix. And it would just be copying Etsy Skell into there and then making sure that has the right ownership, right? Like a CH own. But then, this is something for you to think about. Is that actually required? Yes, no. You might just want to communicate that over to them. Because here's the thing. You could just do this and then close the ticket. Say, I did all the things they asked for. Check the box. Check, 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 check. Cool, I'm a good engineer. But sometimes good engineering like that is not good. I can't tell you how much you have to be like a people person as an engineer. Most engineers, we just want to live in basements and not be bothered by anybody. But I will tell you this, you may make your life a little easier by just kind of doing what we call like a warm transfer or warm handoff. Kick it back over to them, message the person that originally told you it was an emergency and say, hey man, I saw this message. Do you know when you guys log in, do you require a certain set of directory permissions, or do you guys have your own .bash RC? Do you guys even understand what that is? And they might just go, oh yeah, no, don't worry about that. We populate that on first login. And then you go, fuck it, you don't need me at all. And then you go about your day. But if that wasn't the case, and they say, I don't even know what that is, I can almost guarantee you need to go copy that in then, because now they're going to log into some user and assume certain permissions and paths and all these things are set up in an environment, and they're not going to be set. Because if you don't have your .bash RC, you don't do a lot. You don't get a lot. You just kind of drop into a default shell with nothing, and you're almost for sure going to get a ticket back in a few minutes when this breaks. So now you got another ticket to deal with and close out, and it was just something as simple as something you could have just smoothed over. So I'm a big fan of like making my life as easy as possible in this context if I have to. So I want you guys to think about that. All right, so we hit check, and that's it for that. So this week, as far as the admin stuff goes, as far as this is all automation course still, but where do one-off commands come from? What are we trying to do with them? Most of these were tuning the system in some way. We didn't do a whole lot of observing, but we can observe. There's other commands that you can look at that are one-off and ad hoc commands that involve tuning. And then what causes them to need to be run in a system? Why would we do admin tasks in a system? There's a whole bunch of reasons. Something breaks, users need help, security events happen. Those are probably the major ones that I run into. And then we come down here, and again, you're over here doing admin and ad hoc commands or one-off commands to optimize and operate the system and to keep this thing going. Now, a lot of the things we just did, again, to the astute reader and astute viewer, you need to go back and turn them into, you need to make sure the deployer, which the deployer brought you like 95% of the way to a good system, and you just had to fix the last. If you don't always want to be that person that goes and fixes that last thing and gets that ticket every Monday morning, go work with your teams and send what you did back over, and that can be added to the playbook and you never have to do it again. And I'm a huge fan of that, because I've been the guy on both sides of this in my career. I tend to be the guy over here deploying stuff, but then I also tend to be the guy who takes the calls at first. So it's like you never get away from it completely as an admin and engineer. So, all right. If you have questions about any of this, let me know. This is all up in our Discord. You guys are always welcome up in our Discord. It's right here. Discord is there on the Twitch side and here on the YouTube side. This is what the Discord looks like. You can always find all of our discussion posts, and we're only in Unit 4, so you do have time to catch up still if you want. And then if you need to know when the events are, here are all the events that are going on throughout the week, right? And there's always events coming up. They are always free. We've never charged anybody for anything. You're welcome to come and hang out and learn how to get into systems work, learn how to be an engineer. I think this is one of the last places that you can get in without a higher degree in this. You know, you don't need a higher degree to get into Linux administration. And then once you're doing Linux administration, you can move up into engineering roles. But you do need to understand what you're doing. You do need to understand how your automations are flowing and working. And I think that this is a big part of it. So, all right. With that, I'm going to call this stream done because this is just the recording for Unit 4. This will go up into the list of recordings for the course. And if you have questions, just message me down in the Discord. All right. Thanks for coming by, guys. I will see some of you later on today for some of our other meetings. Take care.